Hello. In this video, we will present a case study on displaying prime numbers. We will write a program that displays the first 50 prime numbers in 5 lines, each containing 10 numbers. A prime number is an integer greater than 1, and the integer is only divisible by itself or 1. For example, 2, 3, 5, 7, 11 are prime numbers, but 4, 6, 8, 9, 10 are not prime numbers. The program can be broken into the following tasks. First, determine whether a given number is prime. Second, we can look for the numbers 2, 3, 4, 5, 6, all the way until we find 50 prime numbers. For each number, we're going to test if it is a prime. We're going to count the number of prime numbers discovered, display each prime number, and display 10 numbers per line. We can describe our approach in the algorithm here. Set the number of prime numbers to be printed as a constant number of primes, that is 50. Use count to track the number of prime numbers discovered so far and set an initial count to 0. Set the initial number potential in prime number to 2. So we're going to go through this loop. While count is less than number of primes, we're going to test whether number is prime. If so, we're going to display it and increase the count for the number of primes. Before we go to the loop continuation again, we're going to increase the number by 1 to look for the next number. So now we look 2, 3, 4, 5, 6 this way. We're going to put all this into this program here. So this is the program. The number of primes per line is 10. This is the count, the number of prime numbers, and this is beginning from 2. Here we have this count is less than number of primes. This is the loop continuation condition. We're going to test if this number is prime. So assume it is true, is prime. So now we're going to find a divisor for the number. So starting from 2, and then check 3, 4, and until half of the number. If it's a prime, so its prime is a false, break out of the for loop. If you go through all this, and after the for loop, the is prime is still true, so that is a prime, increase the count, and display the number. This is the prime number, display it 10 per line. So we're going to have this count, remember number of prime per line, and this is divisible by this every 10 lines. So we're going to start a new line, display the number, and start a new line. Otherwise, we display the number, stay on the same line. And now we're going to check the next potential number to see if it's prime. So go back to the loop. So this is how the program works. Now, let's do some exercise. Here is the live example. Now, how are you going to feel this? This is why here is this count is less than number of primes. So we're going to continue now to test if number is prime. Now, after this for loop is finished, it comes out from the break, or it's finished when this condition is not a true. So we're going to look at is prime. If its prime is true, so we are going to count the number of primes. So please note that don't write here is prime is true. So this redundant and could lead to some potential errors if you're not careful. So let's just use is prime. So we're going to count, this is the increase the count for number of primes. So now temp line. So how do you write this temp line? So this is here the count. We're going to have this count remainder number of primes per line. If it's equal to 0, we display the number and start a new line. Otherwise, we display the number, stay on the same line. And now we're going to check the next number, see if it's prime. So this go back in the for loop. Here, go back to check the while loop continuation condition. That is all for this video, the case study for displaying prime numbers. Thank you for watching. See you on the next video.